This is a first lesson in chapter 4, and this is about differentiating exponentials and logarithms. Now, so far, the only work we've done on differentiation and integration has just been polynomials. So this is where it starts to get a little confusing, and you've got some more rules to learn. Before, all you've really had to learn is bring the power to the front, decrease the power by 1. So there's a little bit more to it than this. So for exponentials, which we're going to focus on to begin with, if we have y equals e to the power of something, and I'm just going to call it f of x, some function, then if we want to differentiate this, then what we do is we differentiate the exponent and bring it to the front, and then we just write exactly the same thing again. Now that rule is listed on your formula sheet. So what that means is you need to be able to differentiate whatever this thing is here. So for example, if I had e to the 3x and I said what is the differential of that? Differential of 3x is 3, and then you write down exactly what you had before, e to the 3x. So it seems fairly easy at this point, and to be honest it is. Now also you've got to think about what other questions they could ask you that are related to differentials. So you could be asked what is the gradient of something. You could be asked to find the equation of a tangent. You could be asked to find the equation of a normal. You could be asked to find their maximums and minimums as well. So you might have to differentiate, set it equal to 0. So all those rules that you learnt in AICE 1 are going to apply to these types of questions. I'm just going to focus on the rules for this part, and then you're going to have to refer back to your notes for the other sections. Now, they can get a little more complicated though. So if I said y equals e to the power of the square root of x, then to differentiate that, I need to know what's the differential of the square root of x. So to do that, I might want to make my life a little easier and rewrite it. So the square root of x is x to the power of a half. How do you differentiate x to the power of a half? Bring the power to the front, decrease the power by 1. So in other words, 1/2 x to the negative 1/2. And then we've got to write down the same thing, e to the power of x 1/2. Now we could rewrite this as well. X to the power of negative 1/2, we know, well, power of a half is a radical. The negative means it comes to the bottom. So I could put 1 over 2 radical x here. And the x should be on the bottom here. And x to the power of 1/2 we can rewrite as radical x as well. We've got one more question here. Oops. No problem getting rid of this right now. Let's extend the page so we can see this one. And this one we're going to have to work through. This one's a little bit more complicated. We got a quotient here. Now I know I can rewrite this though, because this is on the bottom. So I could say this is to the power of negative 1. And then now I could use my chain rule to differentiate this. So when you do the chain rule, you bring the power to the front, decrease the power by 1, and then times by the differential of what's inside the parentheses. So if I do that, I'm going to bring the power to the front, I'm going to decrease the power by 1, and then now I've got to times by the differential of what's inside the parentheses. So the differential of 1 is just 0. I got a negative here. So the differential of e to the 2x, you do the differential of 2x, which is 2, and then you write the same thing out again. So we were doing the differential of this, but to do the differential of this, we also have to do the differential of 2x. So it starts to get a little complicated on these questions. You really do have to concentrate on what you're doing. Now, when it comes to simplifying this, 5 times negative 1 times negative 2 is 10. E to the 2x. This with a negative 2 means I can bring this to the bottom. And then I can put squared. So this is what dy by dx would equal. So this was y, and once I differentiated, dy by dx. Also remember, it could just be f of x, and then you can put f prime of x for your differential as well. Okay, let's look at a slightly longer question then. So, perhaps with the application, find the equation of the normal too, and then the equation you can see there, but also in general form as well. So, if we want to find the equation of a normal, we need to find a slope, and we also need to find a point that it passes through. Now, they've given half a point that it passes through. If they've said it went through x is 0, so we should be able to find the y value by using the formula where it says y equals, by plugging in 0 to this. So e to the power of 0, anything to the power of 0 is 1. So 3 times 1 is 3, plus 0 is 3. So the first thing I should be able to say is it goes through the point 0, 3. Now to find the slope, I need to differentiate this. So to differentiate this, I need to differentiate the 2x, which is 2, bring the 2 to the front and multiply. So in other words, 6e to the 2x. Differential of x is 1. Now I want to specifically find a slope at x equals 0. So I need to plug 0 into this formula here. Once again, e to the power of 0 is just going to be 1. 6 times 1 plus 1 is 7. So I have a slope, but the slope that I have is equal to the slope of the tangent. I need the slope of the normal. So to do that, I need to do the negative reciprocal. So in other words, negative 1 over 7. Now, to find the equation of a line, we can use the point slope formula, which you can see here. And I can substitute in my two values. Remember the coordinate I found was 0, 3, and the slope of the normal was negative 1/7. So if I plug those numbers into here, then we get this type of equation. Now the question also said in general form, so this is point slope form, so I've got to keep going a little bit. So I can multiply both sides by 7. X minus 0 isn't going to do a great deal, that's just going to be x, and negative 1 times x is negative x. So if I bring my negative x to the other side, make it positive x, then I've actually got it in general form now, because I've got x, y, and the number all on the same time. But also I have no fractions as well, which is important for general form. So you could have distributed at this point, but it's better to actually get rid of your fraction first when we're trying to get for general form. Take a look on School Fusion, and then hopefully you can answer the assignments for this section.